Hey, welcome back to the pod, everybody. Today we have a very special guest, Sreya Ghosh. Shreya and we worked together for quite some time, and this at this point I consider her a friend and my go-to person for anything data science related. So I'll quickly introduce Shreya and then I'll hand it over to her to introduce herself. So she got into data science from a very academic background. She's a PhD in electrical and computer engineering, and then she did 2 years of postdoctoral work, and she leveraged a boot camp to transition to a career in data science. So she's worked in a bunch of old economy companies, big tech, startups, the whole mix, so to speak.
Yeah, absolutely. I mean, I did make that transition from looking at microscopes to data science, like solving problems in e-commerce. So, yeah, no, that's about it for me.
That's great. That's great. So, if I may, let's get to your origin story, right? So, you were doing electrical engineering, technical field, of course, but fairly different from data science. So, what got you interested in data science? Why did you want to pursue a career in data science?
Yeah, I think everything was kicked off by the Times article that said, data is the new oil. It's like this iconic 2016 quote. People who got into data science back 10 years back will remember that quote. And so, what was data science was kind of becoming a thing. And when I looked at the requirements for data science, I saw that I did have almost all of them. Don't think I knew how to write code in SQL, but other than that, I had a lot of background in image processing, computer vision, optimization algorithms, coding. Of course, I knew how to code in Python and MATLAB for obvious reasons. Academia is very MATLAB dependent. And then data science felt like a good place to apply these skills and also solve like these very interesting problems that were cropping up. And I think in academia, you pursue a lot of things that take a long time to happen. And it felt exciting to move to a slightly faster paced environment into like corporate and data sciencey world. So all those things. So I wanted the fast pace. I wanted to work in this like really cool upcoming field. And then I knew I had a good amount of background to actually dive into data science.
Superb, yes. And I remember that 2016 quote. I think everybody remembers that 2016 quote, and it might have, been instrumental for a lot of is instrumental in bringing a lot of people into data science. So that's very interesting. So it sounds like you had a lot of the, how do I put it, the raw material required for a successful career in data science. You were already familiar with the statistics involved, the math involved, and you had exposure to programming. You knew Python. So the only foundational piece that was missing is how organizations store data and how to retrieve it, which was SQL, as you pointed out. So that should have been a fairly, feel free to challenge this, of course. So that would have been a fairly smooth transition, right? I mean, you have a PhD, you're used to doing research, pretty intensive research, you have the foundational skills, and then you learn SQL and get a job, or it's not that easy. It
So I
requires
would say
maneuvering.
the harder part is getting your resume across because at that point your resume is very academic and you have a bunch of papers, but you cannot really show a lot of like experience in doing like quick small projects across the internet. And then of course your papers are very specific to your field and very hard for a recruiter to even understand like what you worked on. For example, all my papers are in microscopy and nobody would put those two together. So it was very hard to like actually prove that I had these transmutable skills. Like I had all these courses that I'd taken and I applied a lot of that foundational knowledge into actually I worked on restoring three-dimensional images for microscopes, which is very adjacent to image processing, computer vision, anything that you see like modern applications in modern AI systems. But it's very hard to convincingly say that this paper, which reads as three-dimensional microscopy, thick microscope sample, spherical aberration amelioration, is actually an application that corporate can use. And I think that's what the bootcamp really helped with. This focus on a large-scale project with internet scrape data that is a little more easier, a little less mouthful to actually talk to recruiters through.
Okay.
And of course, you're adding like those layers of SQL. You're also adding that layer of very quick coding that you need, kind of that lead code style DSA coding that you need when you start interviewing. Also, just all these basically you're covering more width. I think with PhDs, we are more deep into, we have a couple of choice algorithms and we go really deep into them. The bootcamp, what I did is I covered my width, I did my SQL, I had a couple more projects that were easier to talk to recruiters and then potentially employers about than like very, very deep conversations in microscopy.
Interesting. So you leveraged a boot camp. Are you
I
comfortable
did.
saying which boot camp this was, and do you recommend
Yeah,
that?
it was called the data incubator at that time. And I do want to say there's a time and place for this boot camp. I say that because at that point, data science had become like the silver bullet, and a lot of companies were hiring data scientists without like a full idea of what data scientists were or even what they would bring to the company. So there was a need for data science, and these boot camps opened up, and what it basically did was brought in like really smart kids, high academia, and then gave them a little bit of leverageable skills, basically helped us to do a project that uses some internet data, some missing skills, filled up those gaps, and helped to place us in these companies. What happened subsequently over the next 10 years is that actual courses opened up. So there was no master's in data science, there was no PhD in data science. Nobody had like a degree in data science till I want to say 2018. In 2018, the data science courses started opening up, which were very specific, very catered to data science needs. And then hiring actually shifted from bootcamp to actually university hiring.
Hmm.
And that kind of like changed what these bootcamps did or how these bootcamps operated. I would say there's still a lot of value given to these bootcamps, but I think the market has become a little more muddled right now. But I would say it was very good for me and my friends and colleagues who went through the process with the data incubator right now called the Pragmatic Institute. What's just happened right now that companies have a lot more sources to hire from. So the value is not as inherent as it was at that point.
Right, and you're absolutely right, and it didn't actually strike me. At that point, 8 or 9 or 10 years back, there weren't that many master's programs in analytics, data
There were
science.
none. There were none. It was not a real field. Like nobody studied data science.
Right. And there's a whole bunch now, and a lot of them are remote. So you do it on the side and then you can just transition pretty seamlessly.
Mhm.
So is that something that you'd recommend people to explore, as in at this point, in 2025, not in 2060 anymore? If they're looking for a career in data science, look to do a university degree as opposed to a boot camp?
Slightly harder call just because everybody kind of has like slightly different experiences. If you want to just move into data science, maybe after many years of work experience and you don't want to go back to school,
Mhm.
potentially that's an option. But I think that what I've seen is the trend slowly going towards the recognition of an university degree
Yeah.
over a bootcamp degree. Again, like how it is for computer science and for like a bunch of
Yeah,
other
yeah.
fields.
There's more, yeah. I tend to agree. There seems to be more legitimacy around something a university gives out. But honestly, my perspective is you don't need either. There's plenty of stuff available online for free. You can just teach yourself what you need to know.
The barrier is not your knowledge, the barrier is not the application. I think the barrier is getting your foot in the door.
Yeah.
And there is things that you can put on paper. If you don't go to school A, study subject B, you don't have anything to put on paper. And if you don't have anything to put on paper, getting your foot in the door is really difficult. As
Right.
much as you can leverage contacts and people, but getting your foot in the door is never going to. I think that's complicated. So you need something that you can put on paper.
Yeah, very true. So let me ask you about, so not too long ago, I was looking for a data science slash analytics kind of role. And I didn't actually directly experience this, but I anecdotally hear this a lot that even now, there's a little bit of a bias around some places just prefer it if you have a PhD. And, some places it's not an issue. In my case, I don't have a PhD. In my case, it wasn't a problem. At the same time, I can see why that bias would be there. Like the image regeneration problem that you were talking about that you did in your PhD, that is data science basically. So, first of all, do you think there is a bias? Have you encountered it, or do you?
I would say almost data science roles or ML roles are the only places where a PhD is actively encouraged. I would say most of the other places it's not actively encouraged. So that's kind of a good option for PhDs. Yes, there is a slight bias, and I'll tell you why. One of the big things about data science is there is an element of research in every problem. There is an element of knowing what fits, and something say software, let me talk about the closest next field, which is software engineering or analytics. They're both very deterministic roles where yes, this database exists, give me the sum of this number. But
Yeah.
for data science, there's a lot of exploration and research that goes into these problems. And because PhDs develop like this years of experience in how to research and how to also potentially like prioritize, find paths, I think that years of training is valued in data science more than other roles. So I would agree that there is a slight preference for PhDs. Is it worth 6 years or 5 years that you'll put into PhD for getting that role in data science? That's a little harder for me to say. But yes, I would say there is a slight preference for people who have that PhD background in data science roles.
Okay. Interesting. Interesting. Yeah. And, the people that I know personally who have PhDs and are in the field, I agree with what you're saying. They do seem to be, I don't know how to describe this. They just attack things from a very academic kind of perspective. And I think that helps basically if your boss is a PhD too. Otherwise,
Yes, yes. And there is cultures and there is, I 100% agree there are company cultures that promote that deeper thinking. There are company cultures that do not want that deeper thinking. Not do not want that deeper thinking, but prioritize quickness over deep thinking. And there is always a balance. And truly teams that have PhDs function very differently. And again, because I kind of have been around the block, I have worked in PhD teams, I've worked in non-PhD. There is a very big difference between how these teams operate, function, how they look at weekly updates, how deeply they want you to think about a problem, all these things.
cool. So these PhD teams that you're talking about, did you find that, is it either or in that, the other company where we were working together, that was safe to say it was not a PhD team. The PhD teams that you worked on, are they, are most of the data scientists there PhDs or
No,
no? Okay.
absolutely not. No, I would say a little bit of top down, like if the tops are more PhDs, then how they look at problems are a little different, but absolutely not. I think the teams are very diverse and the teams are, I would say that most of them have a graduate degree.
Okay. Yeah, that makes sense. So culturally it was a
It's
PhD
different.
place, but it's not like a mandatory
No.
must-have kind of thing. Cool.
No, there's no discrimination. How about that? That's, I think,
Yeah.
the right word. There's no discrimination if you don't have a PhD. But let me say that the culture is slightly different when technical leaders have a PhD.
Okay. All right. So moving on from, what background is optimal for a career in data science. So what do you specialize in? From our work together, I know you were working a lot on experimentation and A/B tests and things of that nature. So for the uninitiated, for our audience, can you just talk about what goes into experimentation, what it is at a high level?
Yeah, A/B tests or experimentation is a subgroup within causal systems. And what you're trying to say that, hey, I did A, and is there an effect or is there not an effect? And a lot of companies use these to validate hypotheses uh, around like all these changes they are making. And a lot of companies use this word measurable impact. So every decision that they take have to have measurable impact. And in larger companies, it is even more important than smaller companies. So A/B testing helps you with mathematical foundations to help you to decide whether this change that you enacted, whether it had measurable impact. There is other applications of A/B testing also. These are slightly on the edges, but if you're launching, say, a new algorithm, you want to make sure that it's not too bad. Those are like non-inferiority tests. Those also come in. But A/B testing is essentially taking at minimum two things and saying if this thing happened, there was like this impact.
Okay. So can you give some examples of a real life sort of situation? anonymize as much as you want, but just to
Yeah.
make it realistic for our listeners.
I think I want to talk a little bit about my time at Shopify. And one of the A/B tests that we did was this was a really interesting A/B test. So, what we were doing was actually we found that users who were coming through our app had like just were better users. They were really good. Their MRR, so which is the monthly recurring revenue for them, was higher. They had more likelihood of becoming a customer, all these things. And we knew that our app experience was really good. A challenge was that when people search for you on their browser, you want them to like log in immediately, and you want to get that data, you want them to like start in your funnel. But what we were thinking that what happens, because Shopify is very dense, is when people log in on the mobile browser, what they're experiencing is a very jumbled experience, and there's like a lot of information that they have to parse very quickly. On basically you're taking your large screen experience, condensing it into a very small screen experience. And we were thinking like that was not a great experience for the user, and we were kind of churning these users and getting like a lot of low quality users in. So what we ended up doing is actually turning off the button that that allows the user to sign up from basically the mobile browser. And we were pushing them to go in and download the app and start the experience on the app, because we felt like they would just start with a better experience. But as you can imagine, like downloading an app is a very high friction task, and asking somebody to download an app means that you will churn users right away. So testing this idea would actually constitute to a A/B test, where basically you're testing that, okay, I did this. Did this have any impact on the users? And then the second, so basically you take this experience of turning off the sign up button for half of your users, and another half of your users, you're just letting them do like what they usually did, typically called a control batch. And basically you see like if the numbers, like you have a metric in mind, and you see if the numbers changed positively or negatively for these users who experience the new experience, and then you choose to roll it out to all your future experiences. It's actually very low risk, because you're only turning it on during the duration of the experiment. If
Uh-huh.
you get measurable impact, only then you roll out, and then otherwise you roll back.
Okay. Interesting. So you have two variants of the same thing, and you sort of bifurcate your traffic into the two.
Exactly.
Now, that itself is a involved process, right? How do
So the
how do
gate
you, yeah,
So that happens. There's a lot of ways to do it. Sometimes you do it at you basically do it at the session level or at the user level if you have that information. Engineers typically code it in. It's very obvious if you follow your UTM on your website,
well,
sometimes you'll
yeah.
be in a test set and you kind of have like this number passer out, like you have this number up there that tells you like which test set you are in. And that happens for every company, like everybody's running like thousands of tests on you. So that is, I would say, not something typically data scientists do, because this is engineer experience. So mostly front end engineers or back end engineers help you to set that gate up.
They'll set that up, but how to choose your sample sets, isn't that something a data scientist would do? Like you
Yes.
alluded to some of it, does bifurcating based on session IDs make more sense, or user IDs? And there could
So
be many more. So isn't that something a data
yeah.
scientist would do?
So in the modern data science
Yeah.
stack, like what a data scientist is right now is slightly different from what a machine learning engineer is
Okay.
slightly different from what a data engineer is slightly different from what MLOps is. And
Okay.
data science has kind of across companies almost has been like integrated into being people who are very good at running A/B tests.
Mhm.
And what you'll do is experiment design. And this is like your task. And it starts with first knowing like what is that treatment, then knowing like at what level to bifurcate. That is something important. How long to run the test, and that's like dependent on very hard statistics.
Mhm.
And then of course like once the test results are in, making a decision based on that. But that's like a very academic view of A/B testing. What does happen is 80% tests fail, like they will not show impact. But that is not like, as data scientists in corporate, you cannot walk away at that point. You do have to give an explanation, and also you kind of have to guide like what that next step will be for for like how your stakeholders and how your team, what is that next hypothesis that they will test? Say this failed, what's next is kind of derivative of what the learnings from this test. So all of this is an encapsulation of a day-to-day thing that most data scientists do across most companies.
Okay. And when you say the test failed, you don't mean the experiment itself was not valid. What you mean is whatever your hypothesis was, that you couldn't.
Yes, so the hypothesis is
Yeah.
the change that you did in the product would improve things, and
Yeah.
say it did not improve things by 10%, 5%, whatever
Right.
that number you started with. That is a failed test in the idea that that product has kind of failed, the product update has failed. And that would be enough. In academia, that's enough. And you walk away and you're saying that that's it. But in corporate, you have to analyze and you have to like really look at the data, help to understand like, you have to segment the data, you have to understand the data, you have to understand like what happens if we actually like let this through. Is it like truly a bad experience or is it slightly worse? So there's actually almost like, I would say, art to the science of it.
Okay. Yeah. So sounds like pretty statistically heavy stuff that you have to do.
It definitely is very statistically heavy. There is a lot of companies that have their own tools, and a lot of the statistics is embedded in it. But no, you have to know the statistics very deeply to actually be able to use these tools well, and also to kind of work with corner cases. And I think that's why like data scientists still have a job in this like time and century, because most experiments that you will run are corner cases. So they do not have like straightforward statistics that you can just like pull off the shelf and apply.
Okay. So what kind of corner cases?
Let's talk about a couple. So one is, I worked a lot on mobile experimentation, and Android and iOS can have different behavior. And I'll tell you a very simple reason why. iOS is I would say it's a layer on the North American audience. So most iOS users are North American, and how they buy, how they spend, how they interact is very different from a lot of Android users who are more from developing countries, say India, Brazil. So what happens is there's an assumption of normality in all these tests. But when you look at Android users and iOS users and you choose to segment them, you basically get a bimodal distribution. That means you get two perfectly normal distributions. And how do you reconcile that when you are testing one feature update? So say you change the color to blue. That happened in mobile, and that happened in mobile. So it happened on iOS and Android. Now your Android users are behaving very differently from your iOS users. So that's then you have to start like playing with the statistics to resolve like how do you think about a bimodal distribution over a normal distribution. Another thing that we faced in our company that we worked together was, because if you have to power up your test accurately, our tests would have to run 3 months, 4 months, because we were smaller to medium businesses. And of course, corporate, you can't run a test for 3 months. Like it's not a valid test because the industry changes, you get holidays in between, like everything shifts in 3 months. So bringing the ability to test at a higher power within a small range of time is a very specific it requires a lot of like statistical foundational guardrails, I would say, to actually make those tests valid.
Okay. So that's where the data scientist magic happens, basically.
Mm-hmm,
Not
mm-hmm.
the routine setting up a test and running experiments. Okay, very interesting. So, it does sound like it can get pretty involved. And I'm of the school of thought that, a lot of things you don't need to necessarily, knowledge suffices, you don't need to experience it, especially for people who are looking for jobs and so on. So, to get as good as you are with experimentation, is there resources that you'd recommend? You know?
Yeah, I would definitely say Ron Kohavi's book. It's called Trustworthy Online Experiments is, I think, foundational. You have to read that because it teaches you a lot about. So my challenge with experimentation as a data scientist who works with a lot of stakeholders has been, it's very well known. It's not at all understood. And everybody like really focuses on the p-value, and everybody uses the word stat sig a lot. In fact, we used to have this joke within data scientists that you do a shot when everybody says the word statsig, but the meaning is not exactly what statsig means.
Yeah.
So there's all these like hilarious stories that happen, like everybody's interpreting it slightly differently. And truly, how many times will you correct multiple people? So The challenge with that is there is a lot more to testing than p-values, especially power, especially knowing underlying distributions, central limit theorem. But mostly it's a game of power. So basically, if power is the ability to say that the alternate, so basically you're saying like, okay, this effect has happened. Yes, changing this has actually improved things like 20%. How much do you believe that what you're saying? So there's Bayesian testing, there's Cupid, there's like a lot of like interesting stuff out there. I would definitely start with Ron Kohavi's book. Something that I found immensely useful was like the docs on EPO's website. And that is something we did like a thorough test of a lot of experimentation platforms and found like EPO to be the most statistically sound, but they are very open. Their docs, papers, everything is available online. I would definitely recommend to read that. Also, all experimentation does require a level of understanding of the product. And that is where there's a lot of resources online. But Emma Ding's data science, I would say, is really good if at the beginner level. But then honestly, it comes down to experience. And if you don't have experience, then these three resources. So trustworthy experimentation, trustworthy online experimentation by Ron Kohavi is absolutely number one. Number two would be the Epodocs, and number three would be Emma Ding's, like how to just answer questions, how to think through the product side of things is something I would pick up from there.
Yeah. So the book I haven't read. Heard of it, of course. I'll link to it in the description. And Emma Ding videos, watch credit. She's the YouTuber, right?
Yeah, she's
So
the
those are,
YouTuber.
she does a pretty good job of
Yeah, she
explaining.
does a pretty good job of, and I think at least as more in entry roles, they won't ask you very complex things unless like you intentionally take them there. So I think Emma Ding's videos have that level of ease of like talking through like how a product or how an experimentation decision is made. So I think there's a lot of value in that.
Okay. And the Epo docs, Epo, the company.
Yes.
Okay. All right. I will link to those. So just going back to what we were talking about earlier. So suppose I'm 22 years old, I've just graduated from college and sort of savvy with programming. I know statistics, I'm not hardcore. I definitely don't have a PhD at 22, So what would you recommend to me? I'm sort of inclined towards maths, programming, things like that. And I want a career I'm considering a career in data science. How would you recommend I go about finding my first role?
So the first role is typically going to be the biggest challenge. I think my only recommendation would be to be a little open-minded around the kind of roles available and the jobs that you might have to do. My first job out of academia, where I truly was curing cancer, was in fast food. So let's just talk about that giant leap that I had to make and the disappointment of my advisor. But it gave me a foothold into the industry. And then from there, I could slowly transition into more complex problems and more product based companies that I really enjoyed. So be very open minded about the roles available and what you can do. The second thing is know your fundamentals. And I think that's the only consistent thing that's been true, like even my time in data science over the last 10 years. Other than the math, nothing has really sustained. Everything has been changing. Of course, right now it's LLMs, but truly at the base of LLMs, it is backprop and it is gradient descent. So if you know your gradient descent, know your backprop. And I would say also product is difficult and product is ambiguous. And a lot of times it's very hard to, from outside, to know exactly how your interviewers are thinking about the product. And I still struggle with it a lot. But build a good foundational understanding of what that company is and what is possibly the product that they are trying to build out. And I think that's very important when you are thinking about a job, thinking about an interview, think through these things. But again, I would say if there is something to study that is math, that's the only thing that will last over time. Like nobody's reinventing gradient descent. Applications on top of gradient descent are being reinvented.
Right.
The second thing is be very open minded about the kind of roles that you are looking for. A data analyst role can transition into a data scientist, can transition into an ML ops, industries can transition. So all of these things can happen. So again, like be very open minded about things and then finally have like deep empathy for the product that they are building. So when you're interviewing, understand the product as well as possible because there is like I've never worked at Uber. I don't know a three-sided marketplace, but when you interview, read up on it as much as possible, like maybe even use the app, use the product, understand the flows.
Because that, and you mentioned that a few times. So because that gets tested in during interviews, especially if
It
it's
does.
experimentation heavy, your
Mm-hmm.
interview
Mm-hmm.
questions will basically be around features of the product.
Exactly, exactly. Like know what a two-sided marketplace is, a three-sided marketplace is. If you're applying in fintech, then there's like these like whole set of problems that credit risk, underwriting, things that fintech focuses on.
Right. And since you brought it up, you mentioned your first data science role was in fast food. So what kind of use cases were you dealing with in fast food?
Yeah, it was one of the most interesting jobs I've ever done. First and only data scientist hired straight out of academia, but it was truly a very collaborative and supportive environment. So, what Tim Hortons, this massive Canadian coffee chain, had done is bought out a whole startup and just asked them, like, build us the Tim Hortons app. The advantage of Tim Hortons is that it's very well known. So we reached like within 8 months, I had 1 million users. And as the one and only data scientist, I had a lot of data to work with. And I was literally given a database and literally a data warehouse and said, build us something. Like, we don't know what we are looking for. Again, like, this is data science. We had to hire a data scientist. So the first thing that I did is I built out a lifetime value model. And Tim Hortons, previous to this, is a franchisee model. So every franchisee owns their own data. So essentially, the data was sharded. It wasn't like there was no cohesive look at what a Tim Hortons customer looked like. But through the app, because you can see the customer kind of go to like all these different Tim Hortons locations, it was like the first view into what that customer looked like. And I built out a lifetime value model. Based on the lifetime value model, we built out coupon delivery systems, basket models. So there was a lot of like really interesting data science stuff to dig into.
Interesting. Very cool. Very cool. Okay. And also, so you talked about, I gave you a hypothetical person, a 22-year-old sort of interested in programming and
Mhm.
things like that. Somebody like yourself who's in academia and wants to transition into data science, what advice would you have for him or her?
Build a couple of projects that are a little more accessible, and that could be just something on some version of online data, and then like build an LLM agent or something around it. Have an accessible project. And I think end of the day, getting your foot into the door is dependent on if the recruiter, who's probably is familiar with certain terms but is not as in depth, can understand your project, know your project end to end, build a beautiful website so that you can show it to somebody. I think that is something that's very essential when you transition out of academia, because again, we are very, very deep, but we are not very wide. And especially if you're like me, you've done your master's and your PhD in the same topic. And for me, they were worlds apart. Like my master's and my PhD do not relate at all, but they aren't. They are basically both on computational microscopy. So yeah, end of the day, you have to build a more accessible project. And I know, Omyo, you built one with the Spotify BPM.
Yes.
Despite having like years of industry experience, you also chose to build out like a very accessible project that somebody can immediately understand that you have the skills to build this out.
Yeah, that wasn't data science, but yeah, I get the principle. I'm not very, I don't know web development really. So I wanted to see what goes into it. So I stood up an app and I'll link to that as well now that you reminded me. So your recommendation is, somebody who already has the foundational components to just
Mm.
do a few projects and create a portfolio, basically.
Basically, create a accessible portfolio.
Yeah, yeah. Makes sense, makes sense. Anything that you'd want to leave our audience with, Shreya?
I would say the fun of data science is that you never stop learning. The difficulty of data science is you do fall behind, like if you stop learning even for like a little bit. But I truly think it's one of the more exciting roles that you can have in corporate, and you're constantly being challenged and you're thinking through things. Yeah.
Yeah.
Best of luck to everybody who's looking to get into the field, people who are here already.
Yeah, that's amazing. And one of the reasons why I love speaking with you is you sound excited about data science and how it links to your background and what you can do with it and, just the whole field and why it's exciting. So that's
Yeah, it's like
really great
solving the
to
New
hear.
York Times crossword puzzle for 8 hours, 10 hours a day. It's just exciting enough. Like I used to tell my dad this often that I don't experience flow in anything else other than my work. And a job that lets you experience flow truly, like very, very few people, I think artists, pianists are
Right.
the very few people who get to experience flow. And I think data scientists do get to experience flow and programmers too. But so definitely that's one of the things that keeps me going in data science.
That's amazing. That's amazing. So if somebody wanted to follow you, where can they find you? Do you blog or tweet or
I was on Twitter 24/7, but now LinkedIn would be the best place.
I'll put a link to your LinkedIn.
Perfect.
All right. Thanks, everybody. That's the pod. See you in the next episode. Thanks for being here, Shreya.
Absolutely. Thank you for having me.